Okay, who am I? I've got grey in my beard. I've been doing this a while. At meetups, I like to raise the bottom point, which is the way I got into doing this and traveling from London to speak in Sydney. As I went to my local, I started a little user a group for .NET. At the time when I started in 2003, there were no real big name speakers. It's a very new language. There are about 15 of us, and so we had to kind of like do all the talks ourselves. That got me over the fear of talking. And because it got me over the fear of talking, it meant I started to do community events and then got picked out to do bigger events, right? And it's not because I'm some sort of genius. It's just I got forced into it, but any of you could do it. Come to your local user group or do it at work for your colleagues, friendly audience, people you know and trust, right? And then you can kind of work your way up, honestly. And I'd recommend it to anybody. It's done wonders for my career, and I've been get to do stuff like this. Anyone know I'm a .NET developer? You know that group here? Okay, I work on a messaging framework or an alternative to things like Mass Transit and then Service Bus called Brighter. We're very friendly. We're always looking for new contributors. Paul, one of the contributors, is Australian, but he's in London. What are we going to talk about tonight? So I'm going to talk about this idea of a little kind of recap almost. What is basically domain-driven design telling us about this idea of a single model? And then what I'm going to ask you is, well, what does it tell us about the idea of us having many models? And we're going to find, I think, the answer to that is a tiny bit unsatisfactory. Right. So then we're going to look at what we could do. Actually, those titles are wrong. I think I've changed those since instead. So actually, I'm going to talk about partitioning by use cases, responsibility, and conversation, right? Nothing else. And that'll cover basically actually 3, 4, 5, and then we'll talk about Q&A at the end. So I just hadn't updated the agenda. What's this idea of one model? So hopefully this is a refresher for most of you. So what Eric said about domain-driven design a little bit, the slides are a little bit time to read, but don't worry, I'll talk to them. So it's basically what we want to do is isolate the expression of the domain, model and the business logic, and eliminate any dependency on infrastructure, user interface, or even application logic that is not business logic. So this idea of domain-driven design says, I want to focus on the model, right? And one of the things Eric talks about is too much of the time is spent by developers focusing on infrastructure concerns, on technology, but the model is the really important thing because that's the thing that has long-lasting impact in the business, right? And typically, what tends to happen is some variation of what we call ports and adapters architecture, which is this thing. I have an application in the center. Ports and adapters doesn't say what that is. It could be a transaction script, could be a domain model. And around the outside, I have these adapters. So adapters are just technology concerns that are either going to drive my application. In other words, something coming in from a device or tests or HTTP or a queue or a stream that says, hey, do something. And things that my application are driven by my application. So I put an output to a database, to gRPC, a queue, a stream, right? And that's really all ports and adapters says, right? People get very over complex with ports and adapters and start talking about layered architectures and multiple things. But that's at the heart of it. All it says is separate my I/O and concerns from the business model in the center. And a port is this thing here, which says I plug these adapters into my application through a port, and that forms part of your application. But it doesn't say how you build that. That's why it's called an application. So what domain-driven design kind of says is, okay, when we get inside this area, I'm going to give you some advice on how to build it. And when it was written, right, it's basically of its time, and it's essentially looking at an object-oriented model for modeling basically our application. It doesn't mean we can't take those ideas and say, I'm going to do it functionally, right? But at the time when Eric was writing it, that was the dominant paradigm. And so we get this idea that inside a domain model, we might slice it up into a series of modules. In those modules, we might basically take some stereotypes that he defined. So a stereotype in a kind of object-oriented concern is like a class that represents some kind of pattern, right? So these are the famous patterns. You don't have to use any of them. They were a catalog that helped people at the time, things like aggregates, value types, entities, domain events, factors, repository specifications. So it defines these stereotypes that might help us, and it says we can slice up our space into modules that help us reason about different areas of our problem space. Right? So how do we go about that exercise of creating that OO model, right? And actually, doesn't give you a lot of help, I don't think, right? It infers that you know a lot. So if you read the text and you're around at the time, it makes references to things without being very explicit. So it talks about use cases, it talks about CRC cards, doesn't really explain what they are, right? So for those that don't know, these are classic techniques for how we basically do object-oriented basically modeling. So use cases, this idea of got an actor, the actor wants to achieve something, some kind of outcome, and there's a series of basically things in the software that will help them do that, right? And that's basically a very slightly more complex version of what we use today in, say, user stories. CRC cards, well, literally, you've got a 3x5 index card. You wrote the name of a class on it on one side. You wrote a dividing line and you said, what are its responsibilities and who are its collaborators, right? And then what are its roles, essentially. So you'd effectively tend to model by playing a game. We'd all sit around a table, we'd have a stack of little cards, and we'd say, how are we going to do, say, a customer adding things to their shopping basket? And so we'd say, okay, well, someone needs to be the customer. So you'd write on your card, I'm the customer. And as we go through, we'll start adding roles and responsibilities. Somebody wants to be, I'm the basket, right? And we'd basically come up with a model collaboratively like that. The other thing, the big kind of key to domain-driven design was this idea of ubiquitous language, right? So we'll have a conversation with the domain experts. We'll listen to what they're saying. We'll pick out the terms that they're using, and we'll try and create a model that uses those terms so it's aligned to the actual language of the domain. And that's probably its biggest insight in terms of modeling. Just for reference, so we will understand what we're talking about because it'll become important later. This is what I would think object orientation is, right? So it's this mix of data and behavior. We have some state, we have some behavior that uses that state. We hide the state, we expose the behavior. That is basically a class. You can get base classes, which effectively mean, hey, I inherit somebody else's behavior. And you can get composition, which means I'm made up of behaviors that belong to other classes. And we don't have to worry about dynamic dispatch and message passing to the point of this talk. And then there's this notion of bounded context. Where does that come from? Well, the idea would be to say that there's a boundary around a particular piece of work where essentially we say we want to ensure consistency. So in here, what we want to do is have a consistent model where the ubiquitous language we discuss with the domain experts is expressed in the object model we represent here inside the application. On the outside, then, in terms of this ports and adapters model, that's how we talk to the rest of the outside world. And that's where we get these context mapping ideas like open host, etc. Like rough summary of DDD. Great. And continuous integration is effectively keeping us fit. But Eric kind of admits that a typical system is going to exist basically of a number of models. On a project of any size, people must work somewhat independently on different parts of the system. So in other words, well, I don't want to say words like microservices because that leads us down a particular direction. We're going to have a number of models, not just one model inside one kind of application surrounded by its adapters, but it's going to talk to another model somewhere else surrounded by its adapters. So how do we determine what all these models are? How do I say, well, at this point one ends and this point other one starts? So this idea is what we call partitioning a system. How do we partition a system? Surely, domain-driven design is going to give us tons of really good advice about that, all right? And the answer is unfortunately no, all right? So what it talks about is three things: system metaphor, responsibility layers, and knowledge level. Yeah. So system metaphor. So system metaphor is an idea he borrowed from extreme programming. So extreme programming said, oh, when we think about kind of a large system, we might be able to come up with a metaphor based on something real, like, I don't know, a switchboard or a hospital, and take that real world model and use it as a metaphor to basically figure out what all the parts of our system are. Nowadays, pretty much nobody uses metaphor. And even Eric admits, unfortunately for projects, a few projects have found really useful metaphors, and people have tried to push the idea into domains where it's counterproductive. A persuasive metaphor introduces the risk that design will take on aspects of the analogy that are not desirable for the problem at hand, or that the analogy, while seductive, may not be apt. And I think the problem you get with it is, I've gone to all this effort to create ubiquitous language, which is the customer's view of the world, and then I try and take some other idea completely and merge it on top, and that's really not going to work. And somewhat ironically, in the DDD book, Eric says, there's this idea system metaphor from the XP guys, but on the XP wiki or the XP community was saying, abandon metaphor, let's use domain-driven design. So I go to domain-driven design, and what does it say? It says use system metaphor. So I'm now in a circular hell, right? Okay, so what else is there that he offers? So responsibility layers. So there's this idea effectively saying that layered architectures were a pretty common idea, right? This idea that this layer sits over this layer, sits over this layer, and you have, if you like, increasing abstraction. So I abstract effectively the kind of layer below. I only touch it with a little bit of a few key facades. I don't see most of the detail. Below it doesn't see most of the detail, and it kind of goes all the way down, right? And I thought maybe this is useful. So I can abstract by responsibility and I can layer my system. Well, over time, so basically, you can read the quote, but effectively, refactor the model so the responsibility of each domain object fit within the responsibility of one layer. Layering is kind of a technique that we're moving away from a lot in software engineering. There is some value to the concept, but some of the strict rules often end up with very perverse designs. And in particularly when you talk about SOA or microservices, whatever you want to call it, SOA at one point had very layered SOA, and it proved to be a really bad idea. This idea effectively of, oh, I want to move through layers. I think the responsibility bit is interesting, but I think responsibility layers are not particularly useful. The other idea, which doesn't really help us at all, was knowledge level. So the idea was that we would basically divide our system up into partition things by the level of knowledge. And really what this was about was saying in some areas we may have very dynamic areas of knowledge, and we want to abstract some of the complexity of that away from the users of it, right? But again, it doesn't really tell us how to partition anything. So I honestly think that while Eric admits there are many models, he doesn't really have a very good way of talking about it. So let's kind of take a step back and have a look at what DDD was originally telling us, right? It talked about three key ways of exploring our model: use cases, responsibilities, and ubiquitous language. And I'd offer that probably today we can partition in a very using that kind of inspiration. And I'll only talk about one of them. Responsibilities and depth, and I'll talk the other two gently, but you may want another talk about this. So the ubiquitous language, right? So the idea of the ubiquitous language is we get all the experts in a room, we have a conversation, we use domain terms, and essentially we come up with a kind of model that expresses that. The closest thing probably to that in terms of partitioning is probably our good old friend event storming. How many of you are familiar with event storming? Yay. Okay, good, because I didn't do a lot of depth on that, and also I assumed you would be. This is Alberto's model of event storming. So essentially, the key idea is that you model a whole series of events, things that happen in the life cycle of a given thing that you want to model, right? So talk about effectively a food order. There'd be things like an order is placed, an order is paid for, an order is delivered, etc. And then a question comes up: how do I get to those? Which is the command. What triggers something that effectively causes that event to happen? So customer places a food order, and then what's the state effectively that gets triggered, transformed by that? That's the aggregate or some external system to us. And then there are other things we can look at, which is how does the customer actually make choices? Well, they basically get a UI built out of domain event. So for us, I work at what you call menu log. You're going to pick something off a menu. Where does that come from? Well, someone adds something to a menu system, which results in an event saying, hey, a new menu's been created, which goes into a read model, which then is what you pick from, right? So that's basically the event storm. Typical kind of model. I raise a whole load of events. Don't worry about the guest life cycle for a hotel. That's not what we're here for tonight. And then essentially I start adding in commands, etc., and aggregates. And typically when we partition, we could have a model where we kind of say, oh, well, I could begin to pick out some of these. Potentially they are useful partitions of my system, all right? Potentially these things, and these are repeats, right? You can see potentially these things are the partitions and these are the behaviors they expose. And that is probably what a lot of us today are doing. Event storming became very big, and that became a very big partitioning strategy. All right, I think I've got a few more in there. There's a slight problem with that. So if we go back in history in SOA, one of the big mistakes of SOA was effectively that it chose to use the object-oriented paradigm to define how we partition systems. And service orientation, here where you had a series of operations exposed by a service that effectively hid data and maybe other smaller decomposition, other smaller classes behind it, right, etc. That coupled data and behavior and exposed that as a service. And it was very entity focused, right? I'm going to deal with the restaurant. I'm going to deal with the rooms in a particular case back here. So I'm dealing with the rooms, I'm dealing with registration, I'm dealing with billing. And quite often we ended up in very CRUD-based models, right? So this problem is called entity services. So here, if I have restaurant, cart, account, menu, payment, order, delivery, things that we might think of as aggregates, the problem is much of the business logic often finds itself eating its way up to some kind of API gateway layer that was never supposed to be for that, right? But effectively leaks up into, well, I need to combine the cart and the rest of it. So it kind of bleeds out. So I think there's a danger with kind of this model of event storming that's leading us towards focusing on the aggregates. It's very useful, but I would tend to use it more to describe one model rather than look for how many models work. Partitioning by responsibility is the main one I want to talk to you about. So Nicola just said this big quote, but effectively what it's saying is you need to focus on business processes. Processes are formed in different steps, got activities are tasks and different systems. Excuse me. Priming of the service is a natural step in that functionality. So what he's trying to say in this era was, what we want to think about are what are the business processes that we want to run and how are they sliced up? Just a bit about processes. A process is usually a verb-noun combination that is something your business does, like make lunch or prepare a bill, right? A capability tends to be the thing in your business that actually does that process. Typically, we talk about people, process, and technology, right, as making up a capability. So a given capability might actually cover a number of processes, right? Accounting is going to do a number of processes. Okay, so the capability is how we deliver a given process. And a bounded context, if we think about it, right, is very aligned with some of these ideas, because when we talk about bounded context, it's how we deliver a model. And bounded contexts technically include not just the language, but they include the code, the people, everything that kind of makes up how we're delivering that given model. So I think there's a strong case for saying, actually, when we want to look for bounded contexts in partitioning stuff, we want to actually look towards capabilities, and therefore we want to look towards processes. Okay. So how do we find processes? Right? I said a quote from the microservices paper by Fowler and Lewis saying, Microservice approaches splits up the services to organize around business capability. So it's basically calling for processes. So how do we find them? Yeah, in the walking. So a typical basically model is called value stream mapping. Anyone encountered value stream mapping before? Okay. So anyway, if you get Six Sigma consultants in, they'll spray value stream mapping at you. It's commonly used in industry, but effectively it's a way of saying, what are the processes that make up something we want to get an outcome for the customer, right? Okay. So we walk through the steps, keep an eye on time. Okay. So what happens is we have some kickoff where we effectively say we want to model X. So I think I've got an example here. It's the guest life cycle, which is checking into it, which is basically finding a hotel, checking in, using your hotel room, checking out, right? So you have to agree what you're going to talk about. It talks about everything, so you want to agree a given flow. So flow is typically divided operational and environmental. Operational outcome for a customer, and environmental supports that. So operational flow, customer checks into the hotel. Environmental flow, who stocks my minibar? Right? Very important environmental flow. So you agree what we're going to basically do first of all, kick off, then we do a first walk. So typically, as an idea, we would get some basically post-it notes and stick them on a wall and say what things happen, right? So what things happen, right? I look for a hotel room, I book my hotel room, I turn up at the hotel, there's a check-in process, they make me a key. We all stay at a hotel, right? So we all kind of know that. And then we kind of map that, right, on some post-it notes. So here is an example of me trying to map the guest life cycle. I do some inquiry about reservations, I make a booking, I check in at the front desk, I stay in my room, and I check out at the end of it, right? Probably if I worked in the hotel industry, it'd be better than this, but I don't. So but hopefully you don't. If anyone is in the hotel industry, I'm so sorry. Okay. Then you do a second walk. You walk backwards. So you say from an artifact, like my bill, right? You take it. If you've got a physical artifact, that's one of the best things to do. How did all these items get on my bill, right? And you walk backwards to say, explain this line item. What would it mean? How did that get on there? So you walk backwards on the process steps to check it, right? And then you can add details, which basically are there's lots of things that if an industry are using it, there are things about process time and lead time. You might not need to worry about those. Process time and lead time. Lead time, how long does stuff queue for? Just from how long it takes to actually do the work. And there are things like completion rates. Right. And get out of time if you want to. So it ends up looking something like that on there. And effectively, that is a classical way of drawing out a value stream map. It's a value stream map for the customer. So to these processes, I then inquire about reservation, I make a booking, I check in, I occupy, I check out. Typically, you may say who is involved in this process, right? Which area of the business, how many people are involved. This is lead time, along with basically my queuing, processing time, how long does it take to actually do the work, how many people basically give up at that point. The timeline says, therefore I can see how long it takes. We don't need all of that. You can do a very lightweight version because you probably only need mostly this. But those tend to be reasonably good candidates for effectively breaking up your system into processes which make good candidates to be individual pieces of your software, which effectively you want to model. Slightly different example, but here I'm looking at what I do day to day, which is basically kind of food delivery. And you can see we have a model which effectively does what we call flow. So we focus on behavior, essentially and data flows between the behavior and the process. So I'm putting items into a cart. I need to agree a contract with the customer, which requires taking a payment. That signals I have a contract. I then need to fulfill that, basically, which involves picking goods in a store or cooking stuff, basically in a restaurant. I need to book a delivery, which then goes to a courier to basically do the work. When you're purchasing stuff, a restaurant on boards with us, basically to get the details, which you can then choose from, and we may basically get a menu from them, which then builds a reference data, which we then tend to suck off basically S3 from menu data, right? And so there's a comment here from Michael Nygaard here, Release It fame, but also talks about tendency services problem, saying, I recommend thinking in terms of the services responsibilities. Don't self-responsible for knowing some data. Does it apply policy? Does it aggregate a stream of content into a summary? Does it facilitate some kind of changes? Does it calculate something and so on? And a really interesting point he makes is notice how, as we move through the business process, it causes previous information to become effectively read-only. In other words, when I have effectively paid for this cart and now have an agreed contract for something to deliver, I don't need to modify the cart anymore. I'm done with that, right? I now have a fulfillment request. When I basically sent a request to pick goods and a delivery, I'm kind of done with that. I've now established that fulfillment. And that is a model for breaking up by responsibility, right? So remember, we're looking at three things. The same thing we use when we model individually. Responsibility, this is the CRC card equivalent, and you can actually use CRC cards to play moving your system stuff around the system as a kind of alternative. Conversations, which was kind of what we saw as event storming. So what's the other one? Use cases. So I haven't got time in the session available to talk about this one. If you anyone seen domain storytelling? It's probably only a few of you, so you should probably get a talk about domain storytelling because it's brilliant. So domain storytelling is a bit like a sort of modern version of use cases. So what happens is we draw a model and it says an actor performs an activity on a work item, and we model everything that's happening. So here they're doing, this is a classic example from their site, which is about booking effectively a cinema ticket. So it says a customer asks reservation, so the activity in a work item, right? And effectively, the cashier recommends available seats to the customer. So basically, an actor on a work item, another actor involved as well. I confirm what the seats are, typically in a work item, and effectively get a reservation number. And effectively, a part of this flow, then there's also this flow over here, which is actually me looking at a screen plan to see what the tickets are and get reservation numbers, right? So this interaction, actor and activity against basically a work item, are keys to keep modeling everything in terms of that. It's very similar to how use cases work. This ticketing system is an actor as well. All right, so computer system in the representation is an actor. You can model at different levels, quite high level, what they call coarse grained, or quite low level and fine grained. So you can choose to go into the depth that you want. But this effectively is the modern version of use cases, and it's brilliant. And what you can do there is say, okay, activities that belong together from an actor's perspective tend to be reasonably good partitions of the system, right? So one here, which is about booking probably to me, and one here, which is about seating. So another way you can think about finding relevant partitions. I spend a lot of my time in the past focusing very much on this model as being most useful. We do event storming, but I tend to try and keep that to be more within a single model. But of late, I have found this is really useful. You can generally involve a really broad audience in one of these conversations, and this gets a little bit too. It's very useful for industry, but it's a little bit of we're misusing the tool in a way to do partitioning. And this is kind of my current favorite, but it probably requires a whole separate talk at some point for you. All right. I have about 2 minutes for questions, so you better be fast. Some slack. Okay.
You didn't mention strategic design at all. I mean, you sort of implied it, but responsibilities is strategic design. But then you did talk about the reusing object, taking a concept out of one, not reusing it everywhere, reusing the same concept in different subdomains, rather than trying to reuse the same concept.
Yeah, so responsibility and layers and knowledge bases and etc. come from strategic DDD. I think the trouble is that responsibility bit I think is right, which is effectively why I talk about modeling by responsibility. I think the layering thing is not great. I think it leads to perverse system designs which don't really help us. Layered SOA has never been a good idea. So I think there's hints of what you want to do, but I wouldn't apply responsibility layers. I'd be very cautious about kind of knowledge levels as well, unless I have a specific system that needs to use that. So I don't think it gives you a lot of help. I think there's bits that are related to it, but I don't think it gives you a lot of help actually figuring out how to do partitions.
But strategic design was the biggest revolution since I
Strategic design's bounded context and context mapping are very useful, but they don't tell you how to find the bounded contexts. I think one of the things is that the DDD book is of its time, and it assumes that you are steeped in the culture of its time. It assumes that you know about use cases, you've read Baroque's object design, and know about CRC card design, etc. I think for a modern audience, it doesn't provide so much because you're out of that context in those areas.
When we're speaking about layering here, are we talking about layering in terms of, you talk about layering by responsibility, right? So you're talking each layer like a business layer, presentation layer, or are we talking about?
No, so basically it's talking about dividing up layers of responsibility in the organization. So what it suggests is that in a business, you may have, say, an operational level, which essentially looks after a level below that. And you never took up the operational level, but the operational level governs the things happening at the layer below. And it's an
interesting architecture and services.
Yeah, so each one of those things in those layers effectively is a combination of some aggregates and services, effectively a modules that's clustering together, and so that lives together in that part of the layer. I think so. Like I say, I think the idea that he's focused on there, which is slice things up by responsibility, is probably true. But I think the layering idea, this thing can only talk this way to this thing, is I think unhelpful. Much as it has proven to be a little bit in terms of our individual software design, that overemphasis on layering isn't as helpful as people think.
I like the last slide about the storytelling. I have a question about the cashier on the border of two contexts. Any insights about how to model that entity or cashier itself? Because from one perspective, it has properties, and from another, it doesn't sort of coexist in both domains about topics.
Yeah, so I think it would a little bit depend on what I was doing. If I was building a system where there was a physical cashier who you're meeting in the front of the house, essentially, who is looking at a seating plan, I'm not necessarily modeling them, I'm modeling what their interaction is in reality. But if it's an automated system that I'm building where I want you to talk to a website where the cashier is effectively a computer system, then essentially what you'd have to have is, well, what is this thing? It's probably a service that says, I've got some capabilities, I can recommend something based on what I see here. So probably I'd move it over here, it'd be something that it talks to. But yeah, interesting question. But I'd say probably belongs over here, and it's doing the recommendations to the customer who is effectively tagging to, say, the website or whatever.
Or maybe it can just coexist in both places.
Yeah, it could do.
Name, but
it could be. Yeah, yeah.
Partitioning, partitioning it. So, I mean, if this is the partitioning, how it would reflect upon the teams? Is it like so the teams who will taking care of these partitions, are they like separate teams, or what's the implication?
Yeah, that's a good question. I mean, there are different theories about how to approach this, right? So a kind of strict microservice DevOpsy model would say these are two different teams. If I'm in a team topologies world, I might ask, well, do they have different cognitive? Is their cognitive load enough that I need two teams, or could one team own both of them, etc.? So a little bit, it is various theories about this exist. I would say probably if these two things talk to each other a lot, I would avoid making it one team, because one team would tend to coalesce them together. So I tend to make them two teams, so that the natural fact that the teams had to communicate meant that the boundary would remain in existence. That tends to be my gut, but that's just an opinion, right?
And
you go first, and then I'll come to you.
And if we go to, let's say, I think value stream mapping, I think that's where that's a model which is a little bit easy to understand, especially with the use case you have there, like the checkout. I mean, what I've seen in markets, for example, I've experienced that big commerce one, it was easy to understand, let's say, how.
Yeah. So one of the big advantages of this, certainly for event-driven systems, for example, is you have clear handoffs and parallelizable process steps. So that makes it much easier to basically turn that into a system design.
I think go back to what you said about having separate teams for transitions. Why would you get a single team?
Well, I mean, I think essentially the question would be, why are we broken them apart in the first place if we're going to let a team put them together again, right? So usually the reason we want to separate these two things would either be because the load on one team was too much for them to basically maintain that, or because we felt that the work here was sufficiently different that we weren't going to get the result we needed in terms of two teams trying to think about these two different problems. So sometimes you can find that a team gives these two problems, we know that effectively we need this to be separated, but they'll take shortcuts. So it may just be that we don't want them to merge together because we think that by separating them we'll get a better design, which can happen, right? I may think that getting this team to focus on how the screen plans and reservation numbers work in isolation from this may produce a better model because I won't be too influenced by that model, right? But yeah, I do agree. There is an argument that says if one team owns both of them and they switch them together, it should have been one model originally in the first place. Yeah.
Are these two regions clear-cut separate? I mean, aren't there shared components between the two? Shared services?
Could be.
So that would be a third thing, or is it?
So, I mean, obviously, there are different ways of us responding to what we've discovered, right? And so typically you would have a conversation and decide, what does this mean, right? So there are different ways we could imagine that having gone to here, we would slice this up, right? So I think effectively that there is this ticket system here, right, which essentially says, I know about seats, I know about plans for a screen, and effectively I have a system for reserving the seats inside that in that screen. I may know things about basically what are the best seats, different pricing, etc. Right. So that's one set of domain concerns that I might think about. This one is much more about customer effectively interactions, about saying, hey, you put in your what time you want to see something. I will take that as a kind of set of parameters. I will ask about the available seats. You'll then basically talk about the interaction. So more of a state machine driving the interaction of the customer purchase, right? So I would look at that, but that's only my initial reaction. But your opinion is just as valid as mine in arguing about what this looks like, and say that feels like I'm building a state machine all around the customer interaction. This feels like I'm building something that's all around allocation of seats. We might argue either way, right? We might argue that's one thing, right? We might argue that's two things. We could get into that debate. I don't think the purpose of this exercise tonight is to successfully agree how we're building our cinema system. I think it's more useful to understand from this model, we can, in theory, think about this question, which is activities that belong together from an actor's perspective can be thought of as potentially being a candidate for a bounded context. So I think from the perspective of customer, making my reservation is a quite separate set of activities from the point of view of the ticketing system to allocating seats, right? That's just my, but I want to be clear, that's just my perspective. Yours, if it's different, it's probably equally valid, and we'd have a genuine design meeting to look about those insights and build whatever we thought was correct, right?
Some people will say we don't need bounded context, it can just be one system.
Yeah, it could absolutely be one rather than two. Yeah.
That's why I like mind maps, because then we make no assumptions. We're not drawing little screens, or we're not drawing any kind of ticket machine or something else. We're actually going, well, what's the big picture, and then we find what the subdomains are from the mind map. You know? So the business model.
Definitely. I mean, that could be another. So I think it's not one I'd consider, but yeah, I guess that goes back to more having a conversation as a strategy, which is kind of where we are with the kind of the classical event story model.